So here's the integral that we want to evaluate. Now, just to show you, I actually wrote the whole thing down. So let's just go through it one step at a time. So the first thing we want to do is to make a substitution. Now, based on what is where, I'm going to go ahead and say that we can let u equal sine of x. So we want to write everything in terms of u. So as soon as we have u, we can find du. And that, of course, would be du. The derivative of sine is cosine. Now that we have u and du, let's rewrite this in terms of u's. So this is what we should get here. We should have, let's see, so cosine, check it out, cosine x dx, that's just du, which is in the back. And so there's just 1 in the top. Now the bottom, sine squared is u squared, plus sine is u minus 6. So that's just a substitution. Now, let's factorize this denominator like this. And now we're thinking about partial fraction decomposition and how that this one fraction can be ripped apart into 2 smaller fractions with each factor serving or playing the role of a denominator. And that's just a and b. So now let's do that thing that we did in the other video where we multiply each numerator by that denominator and then eliminate things and simplify. And this is what we should get right here. Once we knock out the denominator using that fraction buster, which is what we called it in the last video. So this is what we should get. Pretty much the shortcut is that's going to disappear. And it's going to be that times that here, and in that operation, and then that times that there. See what I'm saying? Now distribute the a and distribute the b. And that's what you get there. Now put the u's in the front. Up there. And we can factor out a u to the back, like this. And now what we can do is on this side, instead of 1, we can write 1, but a different way, a 0u plus 1. You see that? We can just insert a 0u so that it matches with something u. And then we compare left with right. And so 0 is the coefficient of u, and this is the coefficient of u. So 0 has to equal that, and then 1 has to equal that. And that gives us this system of equations here. You see that in green? We have a little system of equations. And then looking at this equation here, maybe we can move the a to the left-hand side. So it's negative a equals b. And then what we can do is we can write this equation again. But instead of b, we can write negative a right there. And that's what that equation says, right? That equation's here. The b turned into negative a. Clean that up, and that tells you that a is negative 1/5. And by substitution, if you plug that back in here to solve for b, you find that this is the value of b. So now we have a and b. So we can take a and b and plug them in there so that this one fraction gets replaced by these 2 smaller fractions. And that's exactly what happened from here to here. The integral is still there. The du is still there. It's just that this one piece, which is that, became these 2 pieces here. But of course, a and b become the numbers that we found a moment ago. So that's how you go from here to here. Now looking at this there, let's see what happens. So we can separate the addition. So we have integral this plus integral that there, du. I kicked out the 1/5 to the front. That's a negative 1/5. That's a positive 1/5. And now notice that the integral here is just natural log. So that'd be negative 1/5 natural log of u plus 3. Because if you take that derivative, that's exactly what you get. We began with x's. We have to finish with x's. U equals sine of x. And so let's write this again. But instead of u's, we can fill in the sine of x. And that's how we get this there. And look, why don't we write the positive piece in the front and the negative piece in the back? Just switch the order. It's totally fine. And then remember that properties of natural logs. If you have natural log minus natural log, you can go that divided by that as 1 natural log like this. And I also took out the 1/5 to the front because I noticed that they both had a 1/5. So I pulled it out to the front. And then I merged the 2 natural logs into 1, where it's going to be that in the top and in this below. And then just the plus c. And then remember that if you have a natural log, a coefficient can come upstairs to become an exponent. So 1/5 would be the power. But if you have an exponent of 1/5, it's just the 5th root of whatever that is. So this is my final answer. I have natural log, and it's the 5th root of That pink, that's the absolute value. And then it's sine x minus 2 over sine x plus 3 plus c. So this is the exact answer. And if you have a different answer given to you, I'm almost positive that what they gave you is equivalent to that, maybe in a slightly different form. And if it is, you can let me know and I can clarify that. But for sure, that's the result.